Hi everyone, welcome. In this video, we'll be working out this problem. So let's take a look at it. So again, try to read it on your own, understand the problem, try to set it up on your own, and then you can also check back at the end. Let's see what's going on here. So an ordinary annuity pays 7.08% compounded monthly. So this is important. Suppose a person deposits $200 monthly for 30 years and then makes equal monthly withdrawals for the next 15 years, reducing the balance to zero. We want to know what are the monthly withdrawals and how much interest is earned during the entire 45-year process. So this is a problem that involves both future value of annuity and present value of annuity. So let's go ahead and write down those formulas. Here I have both formulas for you written. So make sure you're using these formulas, or if you're using something slightly different where you rename R over N as a different variable and N times T as a different variables, feel free to use that. They're all equivalent. So I'm going to be using these particular ones. So we have the future value of annuity as this formula and present value of annuity as this formula. So they're written right below. So first thing we want to consider is the future value of this annuity. So we're going to be depositing $200 monthly. So R is your constant deposit. So this is $200 monthly, which makes our little n value 12, since the interest will also be compounded monthly. And the rate that we're going to be getting is 0.0708. So again, convert the percentage into decimal, and this is going to be on for 30 years. So I have everything given. We can find the future value. So let's hold on to this on the side. So the future value of this annuity, it's going to be 200 times 1 plus the rate 0.0708 divided by n 12 to the power of 12 times 30 minus 1, everything over 0.0708 divided by 12. So this will give you the future value of this annuity. Now, once you plug this in carefully into your calculator, this will give you $247,880.89. So I'm rounding it to the nearest cent. So this is how much it's going to accumulate to in the future. Now, the second part we want to consider is after this, we want to make equal monthly withdrawal for the next 15 years. Now we're going to consider this as our present value. So if this is how much we have, how much can we withdraw for the next 15 years? So now if you consider this as your present value, so let's suppose P is now $247,880.89, and we're going to use T equals 15. We want to know how much can we withdraw. So R is going to be our question mark that we're looking for. And same interest rate. So the rate is 0.0708. And now we can figure out the rest. Again, we want to figure out the monthly withdrawal. So N is going to be 12. So now plugging all of this into our formula for the present value, you will have P, that's $247,880.89 is equal to R. We don't know. Then we have 1 minus 1 plus 0.0708. So just going to move this slightly. I have a little bit more room to write. Divide this by 12 to the power of negative 12 times T is 15. We're going to divide that by 0.0708 divided by 12. So now our goal is to isolate R. So we're going to go ahead and multiply both sides by this number, and then divide by this number right here. So again, you can simplify them by plugging them in your calculator. So you'll have 247,880.89 times 0.0708 divided by 12, and then divide that by this right here, since R is multiplying that. So we will have 1 minus 1 plus 0.0708, divide that by 12 to the power of negative 180. This is going to be R. And now, if you carefully put this in your calculator, you're going to get R is equal to about $2,239.12. Again, I'm rounding to the nearest cent. So that's how much you can withdraw for the remaining 15 years, since it will have the fund $247,880.89. So that's one of the part answer to this question. What are your monthly withdrawals? So the second answer we just got. And we want to know how much is interest earned for this entire process. So here's how we're going to calculate the interest. So we know this is how much we can withdraw. And we know this is how much we're going to be depositing. So let's figure this out. So we know our interest is going to be total withdrawals. And then we're going to subtract away total deposits. So we're going to figure out the total withdrawal and take away total deposits. So our total withdrawal is going to be $2,239.12. We're doing it every month for 15 years. So that's going to give us the total withdrawal. Minus, now we're going to be depositing $200 for 12 months for 30 years. So that was the first part of this problem. And then if you put this in your calculator, you'll have $403,041.60 minus 72,000, and this will give us $331,041.60. So that will be the interest for this entire 45 years period. Okay, I hope this makes sense. I'll see you next time. Take care.